We're going to start section 3.1, which is about the derivative and the tangent line. So what I want us to do is kind of get some motivation for this whole section. So let's say I have a graph here of some kind of function. And I pick a point on this graph, let's call that point P, and I want the tangent line of that graph, tangent line to that graph right there. So what I've got here is the tangent line of my function at the point P. And our goal, what we really would like to be able to do, is we want to find the equation of this line. That's our goal. So, in order for us to do that, we should stop and ask ourselves the following question. It's a question to ourselves: what do we need to write the equation of a line? So stop and think about it. There are two things you need to write the equation of a line. You need a point, and we need the slope of the line. So first, let's start with a point. If we go back to our picture, we have a point on that line. That point is the point P. So we've already got this part right here. We've got that. It's my point P. So the only other part we're missing is this slope right here. So then we've got to figure out, how do we find the slope of this line? So the answer to that is, what we're going to do is we use secant lines to approximate this slope. So I'm going to go into a little bit more detail. Let's look at a different function here, just so it's easier to picture. Let's say my function looks like this. And here's my point P. And I have some kind of x value associated to this point. I'm going to call the x value C. So this point would be, P would be the point C, f of C. And then I'm going to take another point on this line, or on this curve here, but I'm going to take it pretty close to P. And I'm going to form the line through these 2 points here. So what I've done is I've increased my x coordinate by just a little bit. I'm going to increase it by delta x. So now in this triangle, this distance here is delta x. And then this distance right here, this is what I'm going to call delta y. And delta y, it's the difference in those two outputs, c plus delta x minus f of c. And so now, can I find the slope of this blue line? What would the slope of the secant line, I'm going to call it M, and then a subscript SEC for secant. Well, it's rise over run, delta y over delta x, c plus delta x minus f of c over delta x. So this right here is sometimes what's called the difference quotient. And when you see this delta x, it means change in x. And so what we're going to do is we let delta x get smaller and smaller. So as delta x goes to 0, what's happening is the secant line becomes closer to the tangent line at P. So to get the slope of the tangent line, we're going to take the limit of the slope of our secant line, which was m sec, as delta x goes to 0. And that's how we're going to find the slope of the tangent line.